I keep thinking observability in AI pipelines is just regular observability wearing a cooler jacket, but then drift shows up and ruins the party. The hard part is knowing whether the model is failing because the data changed, the labels changed, or the world itself changed. At a food truck festival, it's like trying to tell whether the taco is bad or your taste buds are the issue after the third spicy sauce sample.
Yeah, that's the part that gets messy fast. Data quality checks catch obvious stuff, but model drift is sneakier. You can have clean inputs and still see accuracy slide because the relationship's shifted.
Exactly. So I like tracking feature distributions, missingness, schema changes, and output confidence together. If the text embeddings start clustering differently or a key numeric feature gets a new tail, that's a warning. Then you compare prediction drift against actual outcome drift if you've got labels soon enough.
Labels are always late. Like, great, thanks, I only needed this yesterday.
Right, which is why proxy signals matter. I'm also fond of slice-based monitoring, by region, device type, traffic source, because overall averages lie to you. One broken segment can hide under a healthy global metric.
And if the data quality degrades upstream, the model gets blamed for being moody.
That's engineering poetry. Also, I keep wanting to add better alerting, but then I procrastinate and tell myself I'm designing the alert taxonomy. If drift is the slow burn, tracing is the flashlight. In a multi-step AI workflow, one user request might hit retrieval, re-ranking, prompt assembly, the model, a post-processor, and then some safety filter that nobody remembers until it breaks. Without traces, you're guessing which step added the weirdness.
Yeah, and the weirdness always shows up in production, never in the happy demo.
Exactly. I want a trace ID that follows the request through every hop, plus spans for each stage with timings, inputs, outputs, and any fallback path. Then when latency spikes, you can tell whether it was the vector database, the model, or that one service that keeps temporarily being slow.
Or the prompt builder that quietly doubled in size because someone kept adding examples.
Guilty, until proven otherwise. The useful part is not just debugging failures, but understanding behavior. If a retrieval step keeps returning irrelevant context, the final answer may look fine until it doesn't. Tracing lets you replay the chain and see where the evidence got distorted.
That replay would save so much time. Right now it feels like following crumbs in a storm.
Exactly, and if we attach metadata to each span, we can start correlating bad outputs with specific prompt versions, model versions, and retrieval settings, which is where the real fun begins, because then you can blame the right thing for once. Which is why logging has to be disciplined, not just dump everything and hope. For AI systems, I want prompts, responses, and tool calls captured in a way that's searchable, time-aligned, and tied back to the trace. Otherwise, you get this fog where everybody swears the model hallucinated, but nobody can show me the exact prompt.
And the exact prompt is usually the painful part, right? Because it's never just the user message. It's the system prompt, the retrieved context, the tool output, the retry, and the little helpful instruction someone slipped in at the last minute.
Precisely. Logging each of those layers lets us see how the final response got shaped. Tool calls matter too, especially if the model is deciding between APIs or chaining tools. If a weather API times out and the model quietly substitutes a guess, that's not a model issue alone. That's a workflow issue.
I like the idea, but logging all that sounds like a privacy landmine.
It can be. So redaction and access controls have to be first class. Log the structure, log the tokens where appropriate, scrub sensitive fields, and make sure the logs aren't just a data swamp with a nice dashboard on top. Once you've got the logs, latency and throughput become a lot easier to reason about. but they still surprise people. Inference pipelines aren't one number. They're a stack of numbers. Queue time, retrieval time, token generation, tool calls, post-processing, all of it adds up. If you only watch end-to-end latency, you miss where the real drag is.
And the drag changes depending on load. It's always fine in the demo and then falls apart when everyone uses it at once.
Exactly. I usually separate 50, P95, and P99 because the tail tells you what customers feel. Throughput matters too. How many requests per second the system can actually sustain before it starts shedding quality or timing out. A fast system that only handles 3 users is not exactly a triumph.
Sounds like some of our services, honestly.
I know. I'm trying to avoid naming names while the tacos are still warm. The other thing is concurrency. Batching can improve throughput, but it can also increase latency for individual requests. So you need to watch the trade-off, instead of assuming more efficient means better.
So basically, the dashboard needs to show whether we're fast, busy, or just pretending to be both.
That's one way to put it, and ideally it should also show when token generation is the bottleneck versus retrieval, because half the time the model gets blamed for waiting on everybody else. Which brings us to the part everyone wants until the alerts start firing at 2 a.m. Alerting on hallucinations and unsafe. Outputs has to be specific enough to catch real risk, but not so noisy that people mute it after a week.
Yeah, false positives get old fast. And with unsafe outputs, one bad miss is still a big deal.
Exactly. So I don't rely on a single detector. I'd combine policy classifiers, refusal rates, toxic language checks, and maybe confidence signals from the model itself. Though confidence is not exactly a truth serum. If a response contradicts retrieved evidence, that's another strong signal. For factual systems, cross-checking against source material is useful too.
But that still won't catch everything. Some hallucinations sound perfectly polished.
That's the dangerous kind. The trick is to alert on patterns, repeated unsupported claims, tool outputs that don't match the answer, or sudden shifts in safety outcomes after a prompt change. And then route different severities differently. Some need immediate blocking. Some need review. Some just need a note in the postmortem nobody will read until the next incident.
That last part feels a little too accurate.
I'm trying to keep us honest. Also, if the festival vendor starts calling something mildly spicy, I've learned to interpret that as a warning, so maybe we need a similar scale for model behavior.